Hi everyone. Today we're going to learn about stepwise regression. And so let's talk about what this is. This is when we have a number of predictor variables, several different things we're going to look at. And we're going to want to know, how do these factors influence one other thing, one other criterion variable. But the way this is different from multiple regression is it's going to determine the optimal model, the best way to combine these factors. Like maybe it's just 2 things together or 4 things together, but it's going to tell you the best model of whatever these predictor variables are to predict this. So it's kind of like it's going to create the perfect cup of coffee. Like it's going to just automatically tell you the right amount of cream, the right amount of Splenda or sugar, the right amount of coffee, the perfect balance, the optimal model for your stepwise Starbucks. Okay? So here's what we're going to do. I'm using SEL practice. This is actually a real research data set that I've used, that I'm actually using and writing a paper right now. And so we're going to play with this. So with stepwise, there's a couple of ways to do this. But first of all, let's talk about assumptions. 1, random independent. 2 would be normal distributions of every variable. And I think by this point you know how to do that, so I'm going to skip that one today. And then the Durbin-Watsons, we're going to make sure that the residuals within this regression model are all normally distributed by looking at the Durbin-Watson statistic later. Okay, so we're going to go to Analyze, and we're going to go to a fit model. We're going to make the perfect model. Computer, JMP, give me a good model. All right, so I want to know if these emotional intelligence scores, interpersonal, intrapersonal stress management, adaptability, and general mood, predict or relate to growth mindset. All right, that growth mindset attitude of embracing challenges and knowing that working hard leads to successful outcomes. So I'm going to go on and put my growth mean score here. It's what I want to predict. And I have 5 variables I want to look at. I'm going to change this degree to 5 because I have 5 variables I'm going to put into this model. So I'm going to hit the control button with this finger, and I'm going to select them. And then I'm going to hit macros factorial to degree. And I'm going to change the personality type to stepwise. Now, I will say this is one way to do it. When you have these little multiplication signs in here, this stepwise model is including the interactions of these variables. This is the way the current JMP guide is written, to include these interactions. However, in a lot of the research I read and a lot of the research I've published, we're not necessarily interested in interactions. Sometimes we're just wanting to know if it's just what's the best combination of these variables, period. See, when you include these interactions, it's saying that interpersonal intelligence, like the ability to work with other people, works in a special way with being flexible. Like those 2 things operate together, or one depends on the other in predicting the growth mindset. That's one way to do it. However, most of the times, especially if I'm consulting with you, and I'll tell you the team with ACT scores, I think you just need to keep it at 1 level. And I'll show you how to do that in a minute. But we just click run, and then this is going to be so fun. We're going to try to run this model so that we get the lowest BIC number. It has to do, I don't really understand exactly what that means, but that's what we're looking for. And so this model is going to take in all of these by step. It's like we're doing a dance. We're going to just keep clicking this step button over and over again until we hear a noise. All right, so let's do it. Step, step, step. And I keep looking at this BIC number. The lowest number is going to be the best model. Step, 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 step. I keep clicking it. Where is the best model? I just keep clicking. Okay, there it is, there it is. So I have found the best model. So what I do is I go all the way down here and I look at my BICs. Oh, wait a minute. Okay, so that's the last one that it had, but where is the lowest one? Actually, it's this one right here, this 177.37. That's the lowest BIC, so that's what I'm going to click. And then I want to look at my parameter estimates. So I'm going to click Run Model. Now what I'm doing here is a forward regression where I'm adding these one by one all into the model, and it showed me which one is the best one. So click Run Model, and then here you go. Now this just looks like your multiple regression. And it's going to churn out the best combination of variables. And what does it show? Oh my goodness, after all that, it's basically just showing adaptability by itself was the only thing that mattered. That's it. Now sometimes this would actually produce a model where it might show adaptability and interpersonal and intrapersonal, that those three do work together, but maybe only one of them is a significant predictor variable. But somehow they are working together in the model to be the best model. You would report all the variables within this parameter estimates model, but specifically discuss and really highlight the significant predictor variable. And remember to click and make sure you look at the standardized beta. Oops, not sort. Looking at the standardized beta. And what is that? Okay, 0.45. That's like the slope. And we can interpret that like Pearson R when it's just one variable here. So that is a pretty large, statistically significant predictor variable. So it's adaptability, it's flexibility that predicts the growth mindset. Doesn't that make sense? All right, so when you report this, you do the same thing that you would with multiple regression. So you report the unstandardized beta, the standard error, the t. This is showing how this slope differs from 0. Does it? And it does indeed. And then this is the p-value related to this t, that the slope is different than 0, and then report the standardized beta. And then you are going to report that this overall model shows that the R squared is statistically significantly different than 0. That's what this F means. So you're going to report the F, the degrees of freedom, 1,69, and then you're going to give me this p-value for your overall model. And then you're going to report the R squared, and this is going to say 21% of the variance in growth mindset is because of the variance in adaptability. All right, now most of the time it's not just one predictor variable here, it's a couple of different ones, and it's saying that this is the optimal model. Okay, so to do regular stepwise regression without building in those interactions, which does make it a little bit complicated. I'll show you that in just a minute. But let me just show you what would happen if I picked a different BIC. Oh, let's just pick let's pick this one right here and run that model. This was not the optimal model, but I'm just saying, what if it was? Then you would still report all of these things, everything that churns out of this best model, but specifically talk about adaptability, intrapersonal and general mood interacting together, and intrapersonal stress management and general mood interacting together. You would discuss those specific predictor variables, but in your table you include all of this. But this is not the best model. The other one was the best model. Okay, so as I said before, the JMP guide discusses how to do this with interactions, but you may not really need to do that, especially if you have several variables. You can just look at how specific ones are predicting it. And how do you do that? You just do it like you did multiple regression. So we're going to put them here. We're going to predict growth mindset. Okay, we're going to go to stepwise personality. And then we can click hitting the button till we hear the noise. But another way to do this, if you don't get as much joy of doing that as I do, you can just click go, and it does it. And then click the one that's the lowest. And again, it is, I'm going to pick this one to be less complicated. It's still just adaptability, and that's what it is. It's showing that again. So make model, and that'll show me, not make model, run model, and it'll show me those results. Okay, so that is how you do that. There's other ways you can do this as well. The J&P guide goes into that. You could also do backwards and see what happens. And I think we'd probably need to run the whole model again to see what happens. But usually when I do this backwards, forward, it still gives me the same result. That adaptability is the same statistically significant variable. And I don't know really why you would want to do backwards. Most everything I read would be stepwise regression, where the computer works forward and adding more variables, more variables, more variables, and then which one is the best model. All right, so let's look at how you write this up. Let me go to correlation write-up, and I'm going to go to make sure you're seeing what I'm doing. Okay. I always wonder who that is online. Y'all are always these little anonymous animals when I'm on here. I don't know who you are, but I'm glad somebody's working on their homework right now. All right, so you just say assumptions have been met. You report the R squared. And so in this one, 4 variables were used, but only 4 variables came out of the model, but only 3 of them were statistically significant. And so those are highlighted. Report the standardized beta, and then you make a table like this. So this includes all the variables in the model, and you want to specifically highlight the ones that are statistically significant. Okay? So that is how you do stepwise regression, and I wish you the very best.